Hello everyone. In this video we're going to be solving a trigonometric equation. We have cosine cubed of x equals negative sine cubed of x, and we're going to be solving for x values. I'll be presenting two methods, even though we're going to get into the part A and part B and some other alternatives. Alright, let's start with the first method. So for my first method, I'm going to put the cosine and the sine on the same side so that this can become a sum of two cubes, and then I'll factor it. Remember the formula for a cubed plus b cubed? We write a plus b, and then that is multiplied by a squared minus ab plus b squared, right? So that's going to be the formula, and we're going to set this equal to 0. Now, we have two factors, and we can set each factor equal to 0. That's going to be our part A and part B. So let's go ahead and split it up. First case, cosine x plus sine x equals 0. Now, this equation can be solved in different ways, so there's a couple ways to go about it. And let me show you the different alternatives. The first method that I'm going to use here within this is basically multiplying cosine x by 1. And what difference does it make? No difference, right? But it actually does when you replace 1 with tangent pi over 4. This is a really cool trick that we use to turn sum of cosine and sine into a single sum. You'll see in a little bit. Now I want to write tangent pi over 4 as sine pi over 4 divided by cosine pi over 4 plus sine x. Now this might be out of the blue, and where does that come from? Imagine you had square root of 3 instead of the 1 there, which is not usually written, right? And then you would replace it with tangent pi over 3, which is the 60 degrees, right? So that would be very helpful again. So now we can multiply both sides by cosine of pi over 4 because it's not 0. And when we do, I'm going to write this first because I want to turn this into something that looks familiar. So sine pi over 4 times cosine of x plus sine of x times cosine of pi over 4. So we multiply both sides by this, okay? And that's still equal to 0. Awesome. Now look at the left-hand side very carefully. And doesn't that look like sine alpha cosine beta plus sine beta cosine alpha? That should remind you sine alpha plus beta, which is a sum. By the way, we can write this as sine pi over 4 plus x. That's the formula. And set it equal to 0. So this is what I meant. This sum can actually be turned into the sine of a single thing. And that's amazing because that really simplifies the problem. Now think about it. Think of an angle whose sine is 0, for example, pi over 2. By setting this equal to pi over 2, you're going to find immediately that, okay, x equals pi over 4 is a solution, so on and so forth, right? Great. So you can definitely go about different alternatives for this problem and, just continue to solve it. But one of the problems that we have with this problem is you have to be careful and always check your work with the original one. Now, we could also do this. And by the way, we're still doing 1a, right? We could just write cosine from cosine x plus sine x equals 0. We could actually get something like cosine x is equal to negative sine x. And now I'm going to do something to negative sine x to write it as the cosine of something. Are you ready? So I'm going to basically take the x and add pi over 2 to it. And again, this is a very cool trick that we use with trigonometry. You should definitely know this. When I add pi over 2 or sometimes 3 pi over 2 or subtract it, the name changes. So you have to think about the cofunction. And the cofunction for cosine is sine. So it changes the name and also the sign, because in the second quadrant, considering that x is an acute angle and doesn't have to be, by the way, the cosine is going to be negative in that region. Make sense? So this does the job, in other words. Now, from here, we basically get two pieces or two parts. One of them is just going to be, okay, x plus pi over 2, which is the stuff on the right-hand side, can equal x plus 2 pi n. And then x cancels out, and this is kind of weird nonsense, right? It's not going to help us. Let's go with the second piece. And the second piece is something like, okay, x plus pi over 2. By the way, I start on the right-hand side. You don't have to. I go in this direction because this has more terms, but you don't have to do it that way. I can just negate it because cosine is even, and cosine of negative x is the same as cosine of x. Make sense? Cool. Now, From here, we're going to get some solutions because bring the negative x over, you're going to get 2x. Put the pi over 2 on the right-hand side, and that's going to become negative. You still have the 2 pi n. By the way, n is an integer. Okay? Cool, cool. Now, a lot of times people make this typical mistake and don't do it. Do not divide both sides at this point because you have a negative angle. And be careful because negative pi over 2 is right here, right? This is negative pi over 2, and half of that is not negative pi over 4. Because you could also express it in the positive direction like this, and its half is going to be 3 pi over 4. Make sense? So be very careful about that. In general, do not divide a negative angle by any integer. But add 2 pi to it, and if you do, that's going to give you 3 pi over 2, and then we don't really care because that's just an arbitrary integer. And now we can divide by 2, and we get x equals 3 pi over 4 plus pi n. Notice that pi over 4 did not pop up here, but it did pop up in the earlier version. You kind of need to check on that, okay? But this should work because definitely 3 pi over 4 gives us a check mark, right? And of course others too. If n is equal to 1, then you get 7 pi over 4, still less than 2 pi, so it's good. Now, that's basically the general solution. N is an integer. And let's proceed now with part B. What is part B? It's been a while, right? Part A was cosine x plus sine x equals 0. Part B is going to be the second factor, which is 1 minus cosine x sine x equals 0, right? And if you forgot that, you can kind of go back to the beginning and look at these factors. By the way, I got to tell you, and I forgot to tell you that, cosine squared plus sine squared is equal to 1. That's how I got 1 minus cosine x sine x. I forgot to mention that. Okay, now, this is our second factor, and this is kind of interesting. I want to write it as sine x cosine x equals 1. And then, do you recognize this? If you do, you'll multiply by 2, right? Okay, so we're going to get something like a double angle. Sine of 2x equals 2. And, this is not real, right? Obviously, because sine or cosine cannot exceed 1. So what is that supposed to mean? It means we should have complex solutions. How do we get to those? We'll talk about that in a little bit. I also need to show you a graph if I don't forget. Anyways, let's go ahead and talk about the second method. Now, after the second method, we'll talk about some complex solutions and we'll look at the graph. So for my second method, I'm going to take the equation as is and cube root both sides. And the reasoning behind that is why not, right? If you cube root both sides, you're going to get rid of the cubes, and guess what? You can cube root a negative number or something with a minus sign. Awesome. You can't do it with the square roots because that's going to be introducing some complex numbers, but again, we can deal with them as well. So from here, we get the same result, and the rest is similar. But let me just quickly tell you, you can do a little different trick here because sine is odd. So you can take that negative and throw it inside and write the negative sine x as sine of negative x. And then turn the cosine into sine, which is going to be a little easier transformation. Have you heard about two complementary angles? They just complement each other, right? If they do, then we can do this conversion and sines and cosines are switched around. That's how pi over 2 or what pi over 2 does. Remember, we talked about it. And then you can just proceed with the cases. Pi over 2 minus x is negative x plus 2 pi n. And the negative x cancels out. Again, this is nonsense. And then go with the second case, so on and so forth, right? Obviously, it's going to give you the exact same solution. So let's quickly talk about the complex solutions. Now, remember, we got sine 2x equals 2. And from Euler's formula for complex numbers, and by the way, check out aplusbi, my other channel, that I focus on complex numbers, but it can be written as e to the power I theta minus e to the negative I theta divided by 2i. I is the number whose square equals negative 1. And by replacing this with that and solving a quadratic, you can get the answer. I want to show you the graph real quick, and we'll finish up with that, okay? Ready? To see the graph of this function, what is that? Cosine cube x plus sine cube x, and we're looking for the x-intercepts, and there they are. Figure out what they are in terms of radians. And this brings us to the end of the video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.